Okay, now we're going to talk about a method called Gaussian elimination. But before we do that, we need to talk about systems of equations and why we need them. So if you'll notice, we have two equations here, and that's because we have two unknowns or two variables, x and y. So if you think about just the equation here, 4x minus 6y equals 14. If that's all the information that we had, we really just have a line. And a line has an infinite number of outputs because it also has an infinite number of inputs. So a basic rule of algebra is that for every unknown that you have, you need an equation for each unknown. So if you only have one unknown, like 4x plus 5 equals 3, you can solve for x. If you have two unknowns, like 4x plus or minus 6y equals 14, then you have to have a second equation with those same unknowns in order to get specific values for your x and your y. And that's why we have to do systems of equations. So if you follow that logic, if I had three variables, say x, y, and z, in order to find out the exact values of x, y, and z, I would actually have to have three equations. If I had seven unknowns, I would need seven equations. So that's how that works. Now, as you can imagine, the more equations you add, the more complex solving the system becomes if you're trying to do substitution or elimination. And so Gaussian elimination is a way that you can organize that information to make it a little bit more accessible, less complex. And so Gaussian elimination focuses on just the coefficients and the constants. And if you think about it, this kind of makes sense because when we were manipulating these two equations, what we were looking at were the coefficient values because we were trying to cancel out a y or cancel out an x. What we didn't really pay attention to were the x's and the y's. They just had to be lined up, but we didn't actually do anything with them, just their coefficients and the constants over here. And so what I'm going to do is I'm going to use Gaussian elimination to redo the problem that we just did, so that you can kind of understand how Gaussian elimination, the formatting, ties into what you're used to with systems of equations. Okay, and so what I'm going to do is I'm going to rewrite this into just the coefficients and the constants. So what I'm going to do is the first thing you want to do is you want to make sure your x's and your y's are lined up in the right columns, and in this case they are. And so what we're going to do is we're going to transfer the coefficients down here. So for the first one we have 4, and for the second one we have a 5, and then we have a negative 6 for that first y value, and we have a positive 3 for that second y value. And then I'm going to draw a line here, and that represents those equal signs. And then we're going to have a 14 here and a 0 here. Okay, that's an ugly 0, so let's get rid of that. Oops, sorry about that, guys. And there. Okay. So, well, I guess we'll just leave the 0. And then we're just going to close the bracket here. Okay. So just to kind of be clear, what I want to do is I'm going to go ahead and use a different color to represent what we're calling each one. So the columns are, these represent the coefficients for our x values, and these represents the coefficients for our y values. And we're going to call this row 1 and this row 2. Okay. Now, the goal of Gaussian elimination is to zero out anything below this right here. So I'm just going to draw a line here. Now, I'm not canceling that 4 and that 3 out. I'm saying that anything below your first x value and your second y value, anything below that, we want to make a 0. Okay. And that's going to make sense here in a second, but that's the goal. Okay. So we're going to go ahead and try to figure out how to do that. So the first thing I want to look at is, how do I make this 5 a 0? Well, the only way to do it is to manipulate the value of the 4 and the 5, right? So I need two numbers that 5 and 4 go into, or I need a number that 5 and 4 go into. So 20 20 makes sense. So what I'm going to do is I'm going to rewrite this, and I'm going to say I'm going to go 5 times, actually, you know what? I want to go ahead and switch that color. So let's go ahead and change that back to black. Okay. So what I want to do is I want to go, okay, 5 times row 1, okay, and I'm going to go minus 4 times row 2. And then what this is going to do is it's going to actually, and this arrow means it's going to replace, so we're replacing row 2 with that value, okay? And so let's go ahead and do that. So 5 times, let's deal with these x's first, okay? So 5 times the 4 minus 4 times the 5. Okay, and so what this right here is, it's just finding out the values for those, okay? And so what that's going to end up giving us is a 0. Okay, so that equals 0. So what I'm going to do is right below here, I'm going to rewrite this. Now we're replacing row 2. So I'm going to go ahead and put row 1 in the way that it is. Okay. And the 14 here. But what I'm not going to do is put in anything for row 2 until I get those values. So we just found out the value for the x, which is 0. So I'm going to go ahead and put that down here. Okay. Now we got to figure out the value for these right here. Okay. So in order to do that, I'm going to look right here and I'm going to say 5 times row 1. So 5 times negative 6 is going to be negative 30. Negative 30. And then minus 4 times row 2. So row 2 is that 3. So minus 12. And so what that's going to give us is negative 30 minus 12 is negative 42. And so that negative 42 is what I'm going to put in right here. And then we said 5 times row 1. So we're going to do these values right here, the 14 and the 0. So 5 times row 1, 5 times 14 is going to be 70. So 70 minus 5 times 0, or 4 times 0 is 0. So 70 minus 0. So that's going to give us 70 there. Okay. Now, obviously, you can see so far we're dealing with different numbers, but that's because the first time we eliminated the negative 6 and the 3, we worked with those y values. But in this case, we're working with the x value. We're zeroing out that bottom x, that second equation x. And so this is what we're left with. Now we can change this back into a system of equations. Because we have the 0 here, we know that this second equation only has a y value now. Remember that negative 42, that represents the coefficient on the y. So what I'm going to do is I'm going to rewrite these numbers as equations. So we're going to say 4x minus 6y equals 14. Okay, so if you'll notice, that's the same as our original first equation. Now we're going to rewrite the second one. We've got 0x, and then we have negative 42y equals positive 70. Okay, and so because this gives us a value or an equation that doesn't have any x values, we can actually solve for y here. And so I'll just go ahead and write that over here. So negative 42y divided by negative 42 equals, let me undo that real quick. So this was negative 42y equals 70. If we divide both sides by negative 42, we're going to get y equals 70 over negative 42. Now we need a number that goes into both. And so 7 times 6, 7 times 6 is 42. So we can divide both by 6 and we get 10 over negative 6, which actually simplifies to negative 5 thirds. And if you'll recall from the first one, that's exactly the value we got for y. So that actually gave us the same value. It's just a different method. And so because we have that value, we can take that, we can plug it back into this original equation to solve for x. And of course, you would get the same answer we did before, which was 1. This is just another method. It's called Gaussian elimination, and it gives us the same results. It seems kind of complex because it can be, and it's a lot to organize, but actually it makes it a lot easier when you're trying to solve systems with more than 2 variables, as you can see on the next problem. So the problem that you have next is well, that's not at all the right thing. The next one that you have is a problem that has 3 equations right here. And there is a video walkthrough that you can watch, but actually I want you to go ahead and see if you can try to do it using Gaussian elimination first before you watch the video walkthrough.